Hi, this is Miss Sek. This is a pre-recorded live class for solving equations with variables on both sides. You will be able to show what you remember about solving equations with variables on both sides. Okay, let's review some vocabulary. The variable in this case is x. A variable is a letter that represents an unknown number. The constants are numbers that have no variable, and the coefficient is a number that multiplies the variable. So equations with variables on both sides have a variable on both sides of the equal sign.
Let's try to solve a more involved equation. So let's say that we have, let me think of a good, say we have 2x plus 3, 2x plus 3 equal to, is equal to 5x, is equal to 5x minus 2. So this might look a little daunting at first. We have x's on both sides of the equations. We're adding and subtracting numbers. How do you solve it? We'll do it a couple of different ways. The important thing to remember is we just want to isolate an x. Once you've isolated an x, you have x equals something or x equals something. You're done. You've solved the equation. You can actually go back and check whether that works. So what we're going to do is just do a bunch of operations on both sides of the equation to eventually isolate the x. But while we do those, I actually want to visualize what's occurring, because I don't want you to just say, oh, what are the rules or the steps of solving equations, and I forgot whether this is allowed or that isn't allowed. If you visualize what's happening, it'll actually be common sense what's allowed. So let's visualize it. So we have 2x right here on the left-hand side. So that's x plus x. And then you have plus 3. Plus 3, I'll do it like this. So that's equal to plus 1, plus 1, plus 1. That's the same thing as 3. I could have drawn 3 circles here as well. Let me just do the same color. Plus 3. And then that is equal to 5 x's. I'll do that in blue. That is equal to 5 x's. So 1, 2, 3, 4, 5. And I want to make it clear, you would never actually have to do it this way when you're solving the problem. You would just have to do the algebraic steps. But I'm doing this for you so you can actually visualize what this equation is saying. The left-hand side is these 2 orange x's plus 3. The right-hand side is 5x minus 2. So minus 2 we could write as minus, let me do this in a different color. I'll do it in pink. So minus 2 I'll do as minus 1 and minus 1. Now, we want to isolate the x's on the same side of the equation. So how could we do that? Well, there's two ways of doing it. We could subtract these 2 x's from both sides of the equation, and that would be pretty reasonable, because then you'd have 5 x's minus the 2 x's, you'd have a positive number of x's on the right-hand side. Or you could actually subtract 5x from both sides. And that's what's neat about algebra. As long as you do legitimate operations, you will eventually get the right answer. So let's just start off subtracting 2x from both sides of the equation. And when I mean that, I mean we're going to remove 2 x's from the left-hand side. And if we remove 2 x's from the left-hand side, we have to remove 2 x's from the right-hand side, just like that. So what does that give us? We're subtracting 2 x's, 2 x's from the left, and we're also going to subtract 2 x's from the right. Now, what does our left-hand side simplify to? We have 2x plus 3 minus 2x. The 2 x's cancel out, so you're just left with the 3. And you see that over here. We took 2 of these x's away. We're just left with the plus 1, plus 1, plus 1. And then on the right-hand side, 5x minus 2x. We have it over here. We have 5 x's minus 2 x's. You only have 1, 2, 3 x's left over. 3 is equal to 3x, and then you have your minus 2 there. You have your minus 2. So normally if you were to do the problem, you would just have to write what we have here on the left-hand side. So what can we do next? Remember, we want to isolate the x's. Well, we have all of our x's on the right-hand side right here. If we could get rid of this negative 2 off of the right-hand side, then the x's will be alone. They'll be isolated. So how can we get rid of this negative 2? If we visualize it over here, this negative 1, this negative 1. Well, we could add 2 to both sides of this equation. Think about what happens there. So if we add 2, so I'm going to do it like this, plus 1, plus 1. So you can literally see we're adding 2. And then we're going to add 2 to the left-hand side, 1 plus, 1 plus. what happens? Let me do it over here as well. So we're going to add 2, we're going to add 2. So what happens to the left-hand side? 3 plus 2 is going to be equal to 5, and that is going to be equal to 3x minus 2 plus 2. These guys cancel out, and you're just left with 3x. And we see it over here. The left-hand side is 1 plus 1 plus 1 plus 1 plus 1. We have 5 ones, or 5. And the right-hand side, we have the 3x's right over there. And then we have the -1, -1, plus 1, plus 1. -1, these cancel out. They get us to 0. They cancel out. So we're just left with 5 is equal to 3x. So we have 1, 2, 3, 4, 5 is equal to 3x. Let me clear everything that we've removed so it looks a little bit cleaner. Clear that out. And then let me clear. These are all of the things that we've removed. Let me clear that out. And then let me clear that out like that. Edit, clear. So now we are just left with 1, 2, 3, 4, 5. Actually, let me move this over. So edit, cut, edit, paste. So I can just move this over, right over here. We now have 1, 2, 3, 4, 5. These are the 2 that we had here. Is equal to 3x's. These guys canceled out. That's why we have nothing there. Now, to solve this, we just divide both sides of this equation by 3. And this is going to be a little hard to visualize over here. But if we divide over here both sides by 3, what do we get? We divide the left by 3, we divide the right by 3. The whole reason why we divided by 3 is because the x was being multiplied by 3. 3 is the coefficient on the x. Fancy word, it literally just means the number multiplying the variable, the number we're solving, the variable we're solving for. So these 3's cancel out. The right-hand side of the equation is just x. The left-hand side is 5/3. So 5/3, we can say x is equal to 5/3. And this is different than everything we've seen.
Okay, so let's practice. 21 minus 5x is equal to 15 minus 3x. Now, to solve for x, we have to bring the variables to one side. So either we can add 3x over here, or we could add 5x over here. So we're adding 5x to both sides. And now we have a two-step equation. When you have a two-step equation, you want to get rid of the constant that's by the variable. So the constant that's by the variable is the 15. So we're going to subtract 15 from both sides. And then the last thing we're going to do is divide by 2.
Hey guys, today's lesson will be on solving equations where there are now variables on both sides of the equation. And a couple of things I want to, clarify is in vocabulary, when we talk about combining like terms and when we talk about collecting like terms, they are very, very similar. Usually when we talk about combining like terms, we talk about one side of an equation. Collecting means collecting everything on one side or the other. So, but both of these I abbreviate often as CLT, and you'll see that in a lot of my videos and in our PowerPoints. Okay, and like I said, since we're going to deal with variables on both sides of the equation, what you have to do is pick your side. When I say pick your side, it doesn't matter which side you pick, but you're going to collect all your variable terms on one side and all your constant terms on the other. So that's kind of our whole chore, is to put everything, all our variable terms, those terms that have variables, on one side, and our constant terms on the other side of an equation. Okay. So our first equation here, 7x equals 4x plus 15. Okay, so what we're going to do is pick our sides. Okay, so I have two sides. I'm going to put my variable terms on this side and my constant terms on the right side here. Now, again, it doesn't matter. I could have picked either way, but let me just give you a little hint. I always look at the coefficient of the variables. And whatever the larger coefficient, in this case, 7, of course, is larger than 4, that's the side I pick as my variable side. The reason I do that is I avoid getting negative coefficients by doing that. As soon as you pick your side, now I want to get the variable term off the constant side. Okay, so I'm going to subtract 4x from this side. But if I subtract 4x from this side, I, of course, subtract it from this side. These are like terms, so we collected all the x's on this side by combining like terms. So that's the CLT. We both collect and combine like terms. This 15 goes along for the ride. Now I have just a variable term on this side, a constant term on this side. Now I'm ready to solve, which of course just means dividing both sides by 3. We have x equals 5. Okay, now what I'd like you to do,
I would like you to take 45 seconds and solve this problem. Okay, now this is for the live class. They're going to get together. Okay, now let's solve it. First thing we're going to do is add 3x to both sides. You could have also subtracted 2x from both sides. That's fine. And now we have a two-step equation. Now we need to get rid of the constant that's by the variable. So we're going to subtract 3. And the last thing we have to do is divide by 5. X is equal to 2. Okay, the live class will do both their assignments during class, but since you're not taking the live class, I would like you to do the line paper assignment. Thank you. See you next week.